Hello there. Welcome to Engineering Drawing Made Easy. Today we are going to work on this tangency problem, and just like the one we did before, this time we are going to try and study the problem, understand whatever it entails and how we'll go about it. And after this explanation, there'll be another video where I use the drawing board and then the drawing instruments to show you how it's done. It's really important that you understand how to do it and then you see how it's done. That makes the learning process a bit faster and it improves the learning process as well. Yeah. So today we are looking at this figure, and as you can see, it has a couple of features, right? Or a couple of, let's say, lines and curves. The first thing you always have to do is study the problem in front of you, try and know all the various parts, what everything does, or what every line means. Yes, and then from there you can go on to seeing how you draw it or recreate it, right? So if you take a look here, we have a straight line, which has a distance of 38 millimeters, right? We have that, and then we've got an arc or a circle of radius 13 here. It touches the line at exactly 1 point here, and also on the other end of the line we have another arc that has a radius of 13 millimeters here as well. Okay, and then there we have another last line here, which is this is a curve rather, or an arc, yes, and that also has a radius of 38 millimeters. So in all we have 3 arcs and one straight line, and all the dimensions here has been given. If you want to note the various kinds of figures or lines or shapes that you have, mostly the dimension helps you to understand that, right? So we have 4 dimensions here, and then I mean we have, it means you have 4 figures or something approaching 4, right? Some of the dimensions you'd have to deduce by subtracting others from others, but then in this case that's not the problem you're dealing with. Here we have 4 features to be drawn, and we have 4 dimensions given. Yes, so you try and understand the figure that you are drawing, and then you go on to the easiest part or the simplest one that you can draw, right? So I mostly prefer to start with a straight line, because I mean it's a straight line. You find the best position on the drawing board and you draw. So I'll start with the straight line. Oh no. We have a straight line of radius 38 millimeters, and then the next thing would be either of the circles that touches the line at exactly 1 point, right? So here you have the circle, and then the center point is in line with the edges of the straight line. Okay, so to show that carefully, this is our point A, this is our point B, right? And you have the circles at both ends. So let's say you draw a center line, on this point. And then you draw the center line here as well. Okay, and from the tangency rule of the tangency rule that states the relationship between a circle and a straight line, we always say that the distance between the center of the circle and then the point at which the line touches the circle is the same as the radius, right? So the distance from this point here, to the center is the same as the distance to the radius. Or the same way that when you come here, the distance from this point to this point at the center is the same as the radius of the circle. So we come back to our center line and we measure at a distance of 30 millimeters. This will be our center point. At a distance of 13 millimeters, this will be our center point here as well. So with your compass, you pin 30 millimeters, and if you do your drawing wall, it should be the same distance from here to here. And you draw an arc. No, this looks ugly. You draw an arc. Yep. And then you move on to the other side with the radius of 30 millimeters. You draw another arc here. Go this way. Yes. You draw another arc. It's always best to understand the figure you're working with and how you are supposed to draw it, right? Because if you take a look, the circle on this edge here goes that direction, and this also comes this direction. So I mean, there is no need drawing out the entire circle. There's no need drawing out the entire circle. Yeah. So I think we are more than halfway done with the figure. The only thing left is this arc here, and that brings us to the tricky parts of this particular figure, right? So the first two arcs or circles were the easiest. Now this has a distinct how do I even call it, property. Yes, let me just say it's property, right? So we have an arc, and how it's the relation between this and this arc here is different from the relation between this and this arc here, right? For the first arc on this point, they are touching externally, because you can see that this arc is coming this way and this is going that direction. So both of them are touching externally. Let me try to trace it over so that you get. So this, if we were to draw it, this would have been a full circle, and this would have been the full circle for this one as well. So they are touching externally. But if you have a look at this end, draw a full circle here, and then you draw a full circle for this one, and then they will be touching internally. I don't know if you saw what I'm trying to explain, but yeah, this is the point that I'm trying to make, that it touches internally at this point, and then it touches externally at that point. So you'd have to go back to the tangency rules and apply them as it's supposed to be done. Yes. Yeah, so let's start with the the end that touches externally, right? This edge here. We are trying to find the center point for this particular arc, and using the tangency rules, the distance between the center of this arc and this particular one is the sum of the radii, because they touch externally. That is one of the tangency rules. So this has a radius of 38 millimeters and this has a radius of 30 millimeters, and because they touch externally, just as I showed a couple of minutes ago, based on the rules, you add the radii of both of them, and that will give you the distance from that particular center at point B. So you're going to have to add 38 plus 13 millimeters. If this lesson is helpful so far, don't forget to subscribe so you don't miss upcoming tutorials. So that is going to give us 51 millimeters, right? 38 plus 13 is going to give us 51 millimeters. So you use your compass and your rule. You measure out 51 millimeters, and then you start at the center point of this arc and draw an arc, right? So like as we did in the previous one, this arc here represents a location where the center for the third arc would be on. So anywhere on this point could be the center for the last arc, right? Yeah. So we go on to the next thing, and that will be finding the distance between this center. That will be finding the distance between this center and this particular one, and that one too. We still use the tangency rules or the tangency principles, and it states that when two arcs are touching internally, the distance between the center is the distance between the two center is the difference between the radii. Yes, you simply just subtract one from the other, and here we have 38 and 13. So you subtract that, and that should give us like 25 millimeters, right? I hope I got that correct. Yeah, so here you come here to point A, because then that is the relation between the arc at point A and the third arc. You open your compass to 25 millimeters, and then you draw an arc. Now, where the two arcs intersect, that gives you the center of the third arc. So with your compass, you open to a radius of 38 millimeters, because that is what is being said here. Radius of 38 millimeters, right? And we found the center. So with the radius of 38 millimeters, you stand here at this point and you gauge where the 38 will reach on this arc. If you do everything well, it should fall on this arc at one particular point, and you continue the circle, you draw an arc. Let me get the curvature right. So you draw an arc from here to here, right? Yeah. let's say it works that way. Try one more time. Yeah, this is a lot better. So yeah, and then since this is an engineering drawing work, you kind of keep your lines neat as much as possible. Yeah. And so there you have it. With this particular one, there are not a lot of different lines or complicated lines as well, but that is how you go. You just have to understand the figure you have in front of you, and then the um, tangency relationships that you would have to use on the work, right? Yeah, it's that simple. So one more time, just like we did the other one. Let me see if I can use different colors to show how to get a third arc, since that is the one that involves a lot of tangency relations, right? From from the center of points, the arc at points B, right? Um, you have the tangency relation of adding the two radii because they touch externally, and the 38 plus 13 millimeters gives us what, 51. So that is the one that we had here, right? Yeah, yeah. So that's the one that we had here. Let me label it. Yeah. Yep. That is 51, and then from the center at point A, right? We had to subtract the two radii because then they are touching internally. So 38 minus 13, that gives us 25 millimeters, right? And that is what we have here. Come on, it's the same color. I barely see the difference. Yes, that is the arc that we had here. Distance of 25 millimeters. So with these two arcs, you get the center for the third arc. Yes, this is a very easy one. Try and understand all the figures that come into play, how the arcs and the lines interact with each other, and you can easily go on to draw the figure. If you have any questions, um, leave it in the comment section, and I'd gladly help you with that. Also, if you have other tangency problems that you feel like you need help with, I mean, it might not be necessarily this one. Any other one that you have that you need help with, you can also leave that in the comment section or in the chat section, and would work on that. It could be featured in the next video.